Welcome to a video on logarithmic differentiation. So find the derivatives of the functions below using logarithmic differentiation and show clear and logical work on the space provided. So number one, as you can see, is pretty complicated. We can solve this using like quotient rule, product rule, but then it's going to be very complicated, which is why we need to use logarithmic differentiation. So we're just going to put ln for both sides. So ln y equals ln of 3. Okay, I'm just going to... Right, and then for these, we can try to simplify it a little bit. So ln y equals ln of x minus 3 to the power of 1/3, right? And then minus, since it's a division, ln x squared ln x squared, and then plus ln 9x minus 5. Okay, so this is it, and then we have ln y equals ln x minus 3 1/3 minus ln x to the second power minus ln 9x plus 5, 9x minus 5. Right, and then so just take the derivative on both sides. So 1 over y times dy by dx equals, we can put the exponent on the outside, so 1/3, and then x minus 3 on the denominator, right? And then minus x squared over 2x. That just leaves 2 over x, right? We're going to write 2 over x here. Okay, and then minus 1 over 9x minus 5 times 9, right? That's going to leave us with 1 over y dy dx equals 1 over 3 times x minus 3 minus 2 over x minus 9 over 9x minus 5. Okay, so dy over dx would ultimately be this whole thing, right? This whole thing, this whole thing multiplied by y, which is also pretty complicated again, but we're just going to write that here. So that everything is in terms of x. So this will be the answer. So imagine that you had to go through product rule, quotient rule, so many complicated things to get to this answer. So I would say logarithmic differentiation is definitely a way to go when you see that there's no other solution, or no other possible way for you to find a solution. And then number 2, I'm going to increase the speed a little bit because we already got through one example. So I'll just say ln y equals ln x cosine x, right? Okay, so 1 over y let me just write this again. Ln y equals cosine x times ln x. Ln y derivative is 1 over y, and then dy dx equals, use product rule for this one, so negative sine x times ln x plus 1 over x times cosine x. Okay, so dy over dx would equal to negative sine x ln x plus cosine x over x, all multiplied by x times x to the power of cosine x. So this will be our answer. Number 3. Okay, similar to number 1 a little bit. So ln y equals ln x squared x minus 4 to the power of 3 sine x. Right? Oh, okay. I'm just gonna put a little parentheses. I'll put parentheses for here too. Okay, and then ln y basically equals ln x squared plus ln x minus 4 times third, and then minus ln sine x, right? So this means that we can do 1 over y derivative of ln y, and then dy over dx. So this is basically implicit differentiation equals, this is 2 over x, right? Because the 2 comes out to the front. and then plus this 3 comes out to the front, so it's like 3 ln x minus 4, so x minus 4 times 3, and then minus sine x, right, and then and then chain rule, so cosine x, right? Alright, so this will be our answer, not our answer, well, one step for our answer. So dy over dx would ultimately equal to 2 over x plus 3 over x minus 4 minus cotangent x all times this, which is x squared, x minus 4 third sine x. Okay, so this is really our answer. And then number 4. Oops. Number 4, ln y, again, equals ln of x squared minus x minus 6 to the power of 1 over x. Okay, so that means that we have ln y equals 1 over x times ln x squared minus x minus 6, right? Okay, so 1 over y dy over dx equals, let's use product rule here. This is basically x to the negative 1 power. It's negative 1 x to the negative 2 times ln x squared minus x minus 6. And then plus x squared minus x minus 6 all over 2x minus 1, right? 2x minus 1 times 1 over x. Okay. Let's see if we can try to do something with this. Dy over dx basically would equal to x squared plus and then this whole thing multiplied by y, which would basically be x squared minus x minus 6 to the power of 1 over x. Okay. Alright, so this will be our answer, and then number 5 is a little bit interesting too. Ln y now equals ln 3x squared minus 5, but then we're going to put the 2 in front, okay, not here. Put the 2 in front of the ln, right, because it's an exponent. If you don't know what I'm talking about, make sure to go back to some logarithmic rules. Yeah, you should have learned that about before. And then 2 ln 3x minus 5, and then plus, right, because it's a product, plus 1/3 ln x minus 4. Derivative of ln y would be 1 over y times dy over dx equals 2 times 3x squared minus 5, and then 6x, right, and then plus 1/3 x minus 4, and then there's no more chain rule for this one. Okay, and then dy over dx would basically equal 12x over 3x squared minus 5 plus 1 over 3x minus 4, whole thing multiplied by this complicated function again. Okay, so this would be our answer. Okay, number 6. Y equals 9 to the 4x power, so ln y equals ln 9 to the 4x power, right? So this basically means ln y is equal to 4x times ln 9. Okay, something really important to note here. You'll see when we take the derivative one more time, so 1 over y times dy over dx equals, and then we see that we have ln 9, right? But then ln 9, if you put that in the calculator, you actually get a constant value, which means that this is a constant value. Yeah, you get a constant value. It's something that you can put in your calculator and get a value for. So this means that you're basically like multiplying something by a constant. Like, just say you're like multiplying, just say to get 5x, right? You're multiplying 5 to x, right? So y equals 5x, and then y prime would be 5, right? So you leave the constant alone. So make sure that you're considering that while doing this example right here. So, you leave the constant alone, so it's ln 9, right, times derivative of 4x, which is 4, right? So that's pretty simple. And then dy over dx is going to equal to 4 ln 9 times our y value, which is 9 to the 4x. The reason why we're multiplying 9 to the 4x instead of just y is because we want to leave everything in terms of y and in terms of x, so that it's actually something that we solved for. So it's not like a mixed things like implicit differentiation. It's more like regular differentiation, but then we didn't use the regular methods that we would use, like product rule or quotient rule. Yeah. Okay, and then number 7, y equals 4 cosine x to the power of 5x. So ln y equals ln 4 cosine x, and then the exponent comes out, so it's going to be 5x times ln 4 cosine x, and then 1 over y times dy over dx equals 5x times ln 4 cosine x. So we're just going to say 5 ln 4 cosine x 4 cosine x, and then plus 4 cosine x all over 4 negative sine x, right? And then times 5x. Okay, so that means 5 ln 4 cosine x minus minus tangent x, or minus 5x tangent x. Yep. And then dy over dx would basically mean 5 ln 4 cosine x minus 5x tangent x, this whole thing multiplied by 4 cosine x to the 5x power. So this would be our answer. Alright, and then moving on to number 8. Again, this one is a little bit complicated. Let's just see what we did in number 1. Well, it's pretty similar, but it's a little bit different, so let's just try this again. Ln y equals ln of, okay, so this is basically, it might look a little bit confusing because of the notation, but this is basically tangent x to the 1/3 times 1 minus x squared to the 1/2 power, okay? Alright, so ln tangent x, and then the 1/3, which is an exponent, comes out, so 1/3 ln tangent x plus 1/2 ln 1 minus x squared, not all over, and then minus ln of 4x squared minus 5, okay? Okay, so derivative of ln y, 1 over y, dy dx equals 1/3 tangent x, right, all over secant squared x. Secant squared x, and then plus 1/2 over, and then chain rule, so negative 2x, right? And then minus 4x squared minus 5, and then chain rule, so 8x, right? So let's multiply y to the whole thing. So secant squared x over 3 tangent x minus 2x. Okay, we're gonna cancel out the 2's. Minus x over 1 minus x squared, right? Okay. And then minus 8x over 4x squared minus 5. So dy dx is equal to this times your y value, which is a pain to write out one more time, but here it is. Alright, so this will be our answer. This is number 8, and then number 9, we have y equals 4 sine x to the power of cosine x. So ln y is equal to ln of 4 sine x cosine x, right? Or this is equal to ln y equals cosine x times ln 4 sine x. Okay, so derivative of ln y, 1 over y times dy dx equals, product rule again, negative sine x ln 4 sine x, and then plus 4 sine x over 4 cosine x, right? And then times cosine x. Okay, so this would be negative sine x ln 4 sine x plus 4 cosine squared x over, nope, cancel out the 4's, over sine x. I'm just going to say dy over dx equals everything times y, which is 4 sine x cosine x. Yep. So we got our answer to be this.